So we're going to talk about relative frequency and experimental probability. So here we've got let's say we'll do a little survey. We have a look at the cars that pass in my classroom and how many of each color pass. Okay, so let's say that all in all, let's say that 10 black cars pass. Let's say 12 white. Let's go for 18 silver, 8 grey, 5 red, and let's say there's 13 of the other colours. So let's see first of all how many cars passed altogether. So 10 to 12, that's 22, 40, 48, 53, 66 all in all. I really hope that is correct, because otherwise I would be showing myself up to be a rubbish maths teacher. Okay, so don't say anything. We've got to work out, based on this, the probability of more cars passing, based on this little experiment that we've done. That is called experimental probability, and another name for that is relative frequency. So relative to everything else, what is the frequency of this colour car going past? So let's work out first of all the relative frequency of the black cars. Now, as a fraction, this would just be represented as 10 out of 66. If we want that as a decimal, 10 divided by 66, I'll put that into my calculator, it is 0.152, there or thereabouts. Okay, white, same again, 12 out of 66. I'm not going to do the decimal this time. Then we'd have 18 out of 66. You might notice that the last two do actually simplify. All the even numbers would simplify. 8 out of 66. This is hard to write on. 5 out of 66, and of course 13 out of 66. What would be here at the bottom, I hear you ask? Well, all possibilities will always add up to 1, or 66 out of 66. Okay, so where is this useful? So we can use this if we're experimenting to predict future results. Okay, now this is a bit of a bad example because this is absolutely no use to anyone, is it? But if we were to predict how many black cars there would be in the next, let's say, 400 cars that pass my classroom. So in the next 400, there's a probability, there's a relative frequency of 0.152 for a black car to pass my classroom. And in the next 400 cars, we want to see how many are going to be black. So all we've got to do, get the relative frequency and multiply it by the total number of cars in this plan. So 0.152 times that by 400, what do we get? We get 60.8. Now, remember, these are actual kind of whole cars. You can't have part of a car going past unless it's been in a serious accident. So, what we'd do, we'd round that. Let's round that to 61. Okay, so once we've done that, that'll be our answer. Now, GCSE examiners are actually relatively lenient when it comes to this, because they would probably accept 60 as an answer as well. However, err on the side of caution, 61 would probably be your best bet. Okay, so that's relative frequency. Relative frequency is just another name for probability. Okay, and it just means that something has been experimented. This is what's come out. Use this in order to predict the future. Okay, so useful in science. It's part of your maths GCSE. That's what you've got to do. Okay, typical example is when they use something like they might say the relative frequency of adding too many crisps to a packet. So too many crisps into a packet is, I don't know, 0.05. Okay, if we're making 1,000 packets of crisps, how many have too many crisps? Then we would do 0.05 times by 1,000. Okay, and of course that would come out as 50 bags of crisps. That's your typical question. That's come up on both foundation and higher tier. And that's what relative frequency means. Just another word for probability. Okay, thank you very much.